But today, in this next 30 to 40 minutes, we're going to be looking and comparing TypeDB with semantic web technologies. And specifically what we'll be looking at here is to cover a topic that we get asked about quite a lot. And that's really asking, how does our technology compare to some certain semantic web standards? So now the first thing before we start to dive deeper and answer the question, how does TypeDB compare to the semantic web, it's really important to caveat this talk a little bit, because it's not a very accurate comparison, if I may say so, because the semantic web we will be looking at and comparing those to how those relate and differ to TypeDB. And those are RDF, SPARQL, RDFS, OWL, and finally we'll touch a little bit on SHACL. For none of those we're going to go very deep, but we're definitely going to touch the surface of what are the key assumptions, the key modeling, the key things to consider with each technology that compare with the other. So we're not going to go deep, but at least what I want is for everyone, especially those unfamiliar with our technology, to have some sort of, I guess, I'm from the Netherlands, in Dutch we would say, some sort of holding on to, that you can start to understand the technology if, of course, you're new to it. But first, to think more high level before we go deeper, is if we look at the semantic web stack and we take it as a whole and we specifically look at those parts that have been more fleshed out, the SPARQL bit, the OWL, the RDFS, RDF, RDFS, XML, and URIs. One of the key reasons where TypeDB really differs, and that's really important if you're deciding your architecture and technology stack, is that if you are indeed using semantic web technologies, not only must you start to, well, first decide what are the technologies or the standards that you'll be using, but also you need to decide what are the implementations of those standards that you need to use. And that's where a lot of complexity hides in the semantic web. Now, of course, if you're very proficient and you've got your favorite technology that you're familiar with, that's great. But for a lot of people, this is a very steep learning curve. You're trying to understand what type of SHACL or what type of OWL do I need in order to actually build my software. And so there's a lot of complexity required in there inherently. And so the main difference here from the outset with TypeDB is that rather than thinking of deciding which component to use in your software, what TypeDB tries to do is to have one software that has made certain decisions on what should be a database that can model complex data, that abstracts away and simplifies the need to choose all these different technologies. Now, TypeDB isn't doing everything that standards like OWL or RDFS can do, but it's what we consider the necessary to build software that works with complex data. And an analogy that we like to make that has really driven a lot of our development and engineering philosophies, that if you consider a stack like the semantic web, like a do-it-yourself computer from the 70s, where you can choose your motherboard, you can choose your chip, the type of memory that you want to put in, which is really great if that's what you want to do. There's nothing bad with it. But what TypeDB here is trying to do is trying to say that, okay, actually, most people, they don't and they can't even actually do that. So let's build effectively an Apple computer where you can't decide on what motherboard to use, what chip to use, and instead you just get handed a box that just works from the outset. And that's roughly the same engineering philosophy or product engineering philosophy that we've taken with TypeDB. So how does that manifest itself? And yes, as the slide says here, TypeDB provides one technology as a higher level abstraction over semantic web technologies. So let's start with the fundamentals, with RDF. Now, an RDF triple, as we all know, I think if you're in this talk, you'll have some familiarity with RDF. An RDF triple is really the core of the semantic web model. And that, of course, consists of a subject, a predicate, and an object. Now, the equivalent model in TypeDB, I think it's a Kraken, is the entity relationship model. And it's really important to grasp the essence and the implications that this has. Because what the model itself in TypeDB is effectively a direct implementation of the entity relationship model. So if you go back to modeling 101, if you start with your conceptual model, your entities, your relations, and let's say you're trying to normalize that data into a relational database, you would go through that normalization process, and from your entities, from your relations, create your tables. Similarly, we would need to normalize our data to fit into RDF triples. And so with TypeDB instead, we can model directly the conceptual model directly in the database in code itself. So how does that work in an actual example? So let's take this here. We've got Peter Parker knows Aunt May. And that triple is represented by effectively the following, and we can add, of course, the namespace where in this case the famous FOAF to represent these triples like so. But the distinction here with TypeDB is that instead of using triples, TypeDB implements a concept level entity relationship model where we consider a person not to be a predicate, not to be a subject, not to be an object, but here to be an entity. And an entity that's connected, in this case, to another entity of type person through a relation of type knows. And then both the person have attributes that are of a certain type and have a value in the form of the name for each person. And this is rooted in, which is in the name of the software, this is rooted in the fact that the type system allows us to model all these different constructs in this way. And also something that should be clear, especially for those that are coming from a semantic web environment, that of course, given that TypeDB doesn't actually work with open world assumptions on the web, TypeDB doesn't actually use public namespaces. If you wanted to use that, that would have to be done at the application layer. So how does this look in code? Now, the XML version of this predicate, of this triple looks like so, and in TypeDB, the query would look like the following. Now, for anyone who's shouting, we will also be looking at other types of serializations, not just XML, but also Turtle and also Turtle. So what we have here is we have effectively modeled on the right here two person entities connected through a relation knows in a relation. But of course, if you did want to add the URIs into the model, we could also actually do that in TypeDB One of the important things here to add to is that in the type system in TypeDB, we are able to actually add attributes to any concept. So even not just relations and entities can have attributes, but even attributes can have attributes. So if you did want to refer to an attribute that has a URI, we can also add that as an attribute if you had to and if you wish to do so, of course. And another key thing of the type system in TypeDB is that is the implementation of hyperrelations. So while in RDF an edge is just a pair of vertices, a hyperedge becomes a set of vertices. And an example of a hyperrelation is what we see here on the left. We've got three things in one relation. We've got a buyer, we've got a seller, and we've got a product, one relation, and that relation is of type purchase. And then on the right, we've got not exactly a hyperrelation, but we did want to show the ability to represent nested relations, where we've got a marriage between two spouses. And then now that marriage, because it's the first-class citizen in the model, that marriage can now also play a role in another relation, in this case, a located relation. And doing this natively in RDF is difficult. And I think one thing before we go further, we're not going to, in this talk, we're not going to go deep into RDF star, which adds more construct. We're just going to look at the basic RDF. And what we want to show here is, first, in terms of nomenclature, the diamond shapes denotes relations, the squares denotes the entities, and of course the arrows denote not the directionality of the relations, because there is no such thing as directionality, but those are the roles that are played by whatever is in a relation. So here we've got effectively a divorce filing relation. That's a three-way relation between Bob and Alice, where the marriage, which is the relation, plays the role of certified marriage in that divorce filing. So it's a very interesting way of modeling this. And so if we focus at these two relations right here, we've got one nested relation and one ternary relation. If we were to model this in RDF, there's several ways of how we could model this. The difficulty here is that while technically we could end up with a model that represents the hyperrelations, and this is only one example of how we could do this, there may be a cleaner way, a better way. The difficulty is that there's no one way of how to model a hyperrelation. And that adds difficulties in the way we're actually making the model. Because ultimately what we'd be doing is reifying the graph to force it to a structure where now a relation becomes perhaps an object, or effectively becomes a node. And that's why in TypeDB, hyperrelations are first-class modeling constructs. So let's look at higher order relations. So let's say we've got a statement, a sentence, a triple here in Turtle, and we want to make a statement about that statement. We want to say that J.K. Rowling wrote Harry Potter in the year 2000. Then, as a side note, can you believe it's been 21 years since Harry Potter came out?
No, I cannot believe it.
It's a long time, 21 years, yeah. Almost a quarter of a century.
I remember reading the very first book when I was like, 12, 11. It's wild. As you were.
Now you can calculate Daniel's age based on that. So yes, here we're effectively making a statement of a statement, in this case that J.K. Rowling wrote Harry Potter in the year 2000. Now, how would we do this in TypeDB? For the initial triple here, saying J.K. Rowling wrote Harry Potter, this will be quite a simple, in this case, we may want to have an authorship relation between a book and a person, where those two entities have attributes attached to one another. And to effectively say something about that relation, we want to effectively say that the authorship relation happened in a particular year. We could simply just add an attribute of type date and value 2000 to that authorship relation. And that's all we would do to effectively state that the authorship happened in the year 2000. Now, another question that sometimes comes up, and that's important just to add as a side note, is that the notion of a blank node does not translate into TypeDB. A blank node really necessitates having to have incomplete data and being in a federated environment natively, and that's not what TypeDB is for. So the idea of a blank node doesn't particularly translate. Let's say if the question is, Harry Potter was inspired by a man who lives in England, and here the blank node is man. The only way, if we don't know much about that man, we could leave that variable open here on the second line on the code snip on the right. We may not define anything. We could even perhaps leave that $M, which is a variable name. We could also not effectively declare that that's or the type of it, and we could just leave it blank as well. Or, of course, we could query it for a thing without a URI if you were modeling things in URIs. But these are, again, examples where we're trying to compare apples to oranges, because the use cases where you are using blank nodes wouldn't really be a TypeDB problem necessarily. That's the really difference in modeling philosophies. So having looked now at RDF, we can move on and look at SPARQL. And now SPARQL, well, sparkles and compares to TypeDB. That was a really bad joke, Daniel.
Yeah, not good.
Yes, I apologize to everyone. Yes. So let's look at how we insert data. We can compare between RDF, SPARQL, and TypeDB. So let's say we want to insert a book with a title, new book, and creator, and other.
Well, that's a great joke.
That's a great joke?
That's a good joke.
Good. That's on purpose. Although actually that's not my joke, I got it from somewhere else. I can't take credit for that. So we're inserting data. Now the SPARQL query may look like this. We effectively want to insert a triple with the right values and to also the right namespace. In TypeDB, if we have the right schema to insert it, we would start with the keyword insert, and then we simply say $B, which is again a variable, is a book, has title, a new book, and creator, another. So we, rather than thinking of having a triple with an object, with a subject, a predicate, and an object, instead we simply insert an entity with two attributes. And that's it. Now, how do we then query for data? Let's say we've got a question and we're asking who are all the persons that Adam Smith knows. This is a slightly more advanced, or I guess slightly more difficult query. And here we're doing a slightly bigger traversal, where in TypeDB we could do it as follows, where we're fetching for data, we're asking for a person that has a family name, Smith, has a given name, Adam, and then that person, which is $P, is connected to $P2, which is connected through a relation of type nodes, and then we are fetching for $P2, which is anything that can be in that relation can be connected, and the get statement here is equivalent effectively to saying select in SPARQL. And a more complex query would be the following: give me the director and movies that James Dean played in, where also a woman played a role, and that woman played in a movie directed by John Ford. Now that query could look like so, and in TypeDB we could look at a query that looks like this. And the key difference in thinking of this particular traversals that I want to highlight here is, rather than thinking of this as a pure traversal from start nodes to end nodes, we can now actually use the hypergraph model to actually consider this query differently. If we look at the actual traversal, from a RDF point of view, we're really querying between subjects to objects, from nodes with edges to other nodes. But instead here, we can actually use the hypergraph model, and also the entity relationship model, where we're considering the use of roles to denote the way we're actually representing effectively the context of the query. Because we want to say here that James Dean plays the role of an actor in a casting relation. And in that casting relation, there's also a movie that plays the role of casted movie, where a woman plays the role of actress, and etc. We can think differently in the query. We can think differently. We can think more higher level. Now, with that, we can look now at RDFS, which for I hope most of you are familiar, is effectively RDF with some more advanced or I guess basic ontological construct before we get to OWL. Now, one of the great things about RDFS is the ability to have classes. And so let's say we're modeling a horse, which must be a subclass of an animal. If we're using, let's say, an XML, we can model it like this. And in TypeDB, we model it like so. The keyword sub here is important. The keyword sub in TypeDB defines that something is a subtype of something else. And here we see that animal is an entity type. But then we also say that horse is a subtype of animal. So all horses are animals, but not all animals are horses. And we can do the same for relations. So let's say we've got an employment, and we've got different types of employment relations. So for example, a part-time employment relation. We can very easily also model that using the keyword sub. Here we're saying that part-time employment, sub-employment, effectively states that a part-time employment is effectively that. Now, a common question we also get is the ability to do multiple inheritance. Something important to mention is in the TypeDB philosophy, multiple inheritance is not supported out of choice, in the sense that we enforce single type inheritance. And let me explain why. So first, here in this example that we want to give, we've got an employer, which, at least in the RDF model, we want to model as a subclass of company and a subclass of government. In Turtle, that could look like so. We could quite easily, quite cleanly define that. And this is where it gets really different, because something that RDF doesn't support is the ability to create roles. And the ability to create roles basically avoids you, or let me say, the use of roles is used instead of multiple inheritance. Because in the example where we're having employers as being subclass of companies and governments, we actually want to assign a role of employer or effectively employer to either the company or the government. Because the government is not always an employer. Yes, it'll always have employers because that's just how it works. But the notion of being an employer is not an actual entity. It should be a role. And so that's really important, and that's what we model in the relation, rather than modeling as a class. So TypeDB supports single type inheritance, and TypeDB prefers composition over inheritance through roles. Another construct is RDFS domain and RDFS range. Now, the ability to do RDFS domain is, of course, very useful. If we have a predicate where we want to say that anything that is the subject in a published on predicate must be of class published book. In TypeDB, we simply use a rule to make that inference. Because of the nature of TypeDB, because of it's not built for the web. There's no native support for domain, for RDFS domain, RDFS range. And instead, we simply use the rules to infer whatever concept we want to infer. And this is done, again, in a closed world environment using closed world assumptions. And the same is true for here for RDFS range. If we want to say that if a sibling, if someone plays the role of brother in a siblingship relation, they must have, in this case, the attribute gender with the value male. And we can take a look also at a more complex example. If we say that if we have a vessel of class departing vessel, which has the property next departure specified, we could state that vessel is of type class, departure vessel is of type class, next departure is effectively a property. Queen Elizabeth II is a vessel, and Queen Elizabeth II has the next departure March the 4th, 2010. Now, with RDFS domain, any vessel with next departure will be inferred to be a departing vessel. And that would make Queen Elizabeth II a member of the departing vessel class. But in TypeDB, we write a rule that connects any entity with the next departure attribute to the departing vessel role. So here, any $S type that has an attribute next departure of any value, so $ND, can play a role departing vessel in a departure relation. So now if we insert this data, so we have a vessel that has a next departure, and we see that the value here is filled in. TypeDB will now infer that Queen Elizabeth II plays the role of departing vessel in a departure relation. And voila, that's effectively mimicking what this particular RDFS range is trying to do. Now let's look at OWL. Now, we're not going to go through all the main axioms and all the theory behind it, but we will be looking at a couple of the main axioms that are used. So looking at OWL restrictions, if we look at all values from, where if we want to say that the range of has parents with person animal classes can only have person parents and animal parents values, we want to basically say that, well, Daniel has a dog, but he's not the biological father of his own dog, right?
That's correct. But I do feel like a parent.
Daniel feels like the parent, but he is not the real parent. There is a dog parent, and so so here we want to make sure that the schema captures that. Sorry, Daniel. So the restriction here in RDF and RDFS in OWL, we can quite simply do it like so. But the restriction in TypeDB we can also make, not using effectively a restriction class in OWL, but simply using the scoping of the right roles and the schema restrictions that are enforced at the database level. That's very important that we haven't really touched on today, is the ability to really represent schema and have safety of any data going in and out. And here we're saying that a person that plays the role of child only in child parentship can be effectively a child. And those relations are declared and defined at the bottom, where person parentship is, and the same goes for an animal parentship, are sub-relations of their parent, which is an abstract relation, a parentship relation.
So we're able to scope the role that a thing would play to a specific relation.
That's right, Anna. And we also can do transitive properties. Now, we can quite very neatly, effectively represent a transitive relation here if we want to say that if the UK is in London and King's Cross is also in London, we can infer that therefore King's Cross is also in the UK. And that's represented through a rule in TypeDB where we say that if A is connected to B and if B is connected to C, then A must also be connected to C. And then in this inference will run every time you query for the database. So with this rule, if we then insert that this information, whereas you can see that A, which is London, is connected to B, which is the UK, and if B, which is the UK, is connected to C, which is Europe, this query will now return, which is effectively saying that this match $B as a continent has name Europe. The $A here will return not just the UK, which we have inserted, but also London, which is not persistent. And we can also do equivalent properties. Let's say someone that has borrowed a book has also checked it out, and that's also something that we can model here using a rule in TypeDB. And if we want to infer that red wines should have the color red property, we can infer that with this restriction and also with this rule here that says that if anything is of type red wine, they must also have an attribute of type color with the value red. So finally, we want to look at SHACL, but only on the surface, because one of the important things of TypeDB is the ability to do schema validation, or just general, the ability to do schema and guarantee safety at the database. So if we want to restrict a person to work for a company and restrict a company to have a name attribute of data type string, in SHACL we could do it like so. And in TypeDB, we would represent that at the schema level. And again, this is really important because rather than having to use something like SHACL and add it to your architecture, you can effectively use validation in schema right out of the box. And here we say that a person can only play the role of employee in an employment relation. Company can only play the role of employer in an employment relation. And we say that that employment relation relates to those two roles. And finally, we declare the data type of the attribute name. So, to summarize, TypeDB reduces the complexity while maintaining a high degree of expressivity. That goes back to my example of the do-it-yourself computers from the 70s and the Apple. TypeDB provides a higher level abstraction for working with complex data, and semantic web standards are built for the web, whereas TypeDB works for closed world systems with private data. And as a final note to leave you with, if you're looking to switch or if you're considering using TypeDB, one of the main things to consider is that while of course it's not as low level, that's the point of TypeDB. The TypeDB provides one technology as a higher level abstraction over semantic web standards. So with that, thank you very much, everyone. Thank you for sticking to the end. And I am very happy if there's any questions. But I would also encourage, if anyone wants to share what they're using TypeDB for or think they could use it for, I would really like to have a conversation right now. And I know Daniel does he's got the power to unmute you and bring your voice to life. So.
Indeed. So first of all, thank you, Tomas. Well done as always. And to everybody else that is watching, either on YouTube or Facebook, feel free to drop any questions in the chat. If you've joined us on Zoom, feel free to share any feedback, curiosities, ideas, thoughts, questions. You just have to hit the raise hand button in the Zoom menu. And I can bring you off mute, and you can share with the rest of the group.
What if I raise my hand, Daniel?
Tomas, would you like to share something?
No,
No. Okay, you just shared.
I think I've shared enough.
We'll take it from here if you don't mind. I want to just go to the chat really quickly. Fernando asked or commented that he thinks that URIs could be class properties rather than object properties. In one of the examples, and bringing that up to say, how do you see URIs? How have you seen URIs used in TypeDB? So, if I listen to that comment, if that assumes that there's a one-to-one mapping between classes and objects to the TypeDB model, that's not true.
the whole point of using the model in TypeDB is that you have a different model, the entity relationship model, concept level schema effectively, where the way you would have modeled things using triples will not be the same in TypeDB. And so the effort that you're making to make that migration to use that other data model in TypeDB is because you have this other model that you can use. So how that works with what URIs you want to keep, that's up to you. I don't really have any view on that, nor am I the best person to give advice on that. But I would emphasize that point is that if you are using TypeDB, technically you can, of course. But if you're asking me, can I make a one-to-one mapping between a semantic web model and or triples and TypeDB, that's basically like asking, can you make a one-to-one mapping between effectively between, let's say, C and Python. You're talking different languages effectively at different levels of abstraction. So those are the things to think about.
And so just without, without calling out our newest members, but actually calling out our newest members, just to hear what you thought. Our Benston Evans, you had said you were a newbie. Would you be willing to come off mute and share a little bit about your reaction or thoughts coming out of this? Would love to give you the floor. Ken asks, is TypeDB compatible with Portuguese?
With Portuguese, well, yes, in the sense that if you want to make you can name your types anything you want. The type system in TypeDB is just like any other language or programming languages, doesn't really discriminate what language you use. But of course, the actual keywords like ISA, entity, relation, all of those are, of course, in English. But just like any programming language like SQL would have. So yeah, I'm not sure what all else is. Yes, it's compatible with Portuguese, I would conclude.
It's a great question. So hello, I believe we got you off mute now.
Is your sound on?
There we go. Hello.
Okay, hello. Can you hear me?
Yes.
Yes.
All right. Yes, some of this takes me back to an AI class I had years ago. Using Lisp, properties and all of that sort of stuff. So, I'm looking at it now from the point of view of, I guess, blockchain systems. So I guess that's, I guess that's why I sort of like got into this, online meetup to kind of see, how is that possible? Because unlike in this where you have static data, if you were using, say, smart contracts, or you can think of it as stored procedures in other databases, you would be actually using logic to maybe sort out some of those relationships. So I was just more curious about that.
Cool. Do you have a specific question you'd like to discuss? I mean, firstly, welcome. Where are you calling from, by the way?
I'm in Brooklyn, New York.
Right. Great. As your hood.
Yes, that's where I was prior to coming to London. I would say I dropped the link to our Discord in there as well, as I know there are a number of community members that are thinking about the blockchain space and how TypeDB might be incorporated in an application therein. So we'd really encourage you to join in and introduce yourself and let the folks know that where you're interested. And I know that there will be a few that reach out and would love to chat.
Yeah, I don't have a specific question, but I guess I just wanted to let you know what my perspective was. In a sense.
Thank you so much.
Yeah.
Really appreciate it. And welcome. We hope you join us at either tomorrow or the following weeks.
All right. Well, thank you.
Our pleasure. See you soon.
Yeah.
Let's see here. Patrick. Hello, Patrick. Patrick says, the separating state from structure, can you describe how one would represent changes to state and structure over time? In other words, when modeling the world, things change, i.e. roles. Assertions at 10 may be proved wrong at 11, but you still want to be able to traverse the model at any time. Hard to ask, well, in constrained venue, of course, but how does it resonate?
Yeah, I think it's assertions at T0, maybe at T1. Yeah, time 0 and time 1. Yeah, no, okay. I think, honestly, I think the short answer is if you're looking to represent different changes in state and structure, is to model some form of time model in the model. I think one of our community members has done some work that is publicly available that also gave a talk. Did Brett talk also about this time series work?
Yes, and it is on our YouTube channel.
Okay.
I can drop the link in the chat as well, but obviously head to our YouTube channel and you can find it there.
So I think one of the very important ways of going about doing so, I mean, firstly, you can quite easily represent a relation that represents some sort of state with attributes denoting the time that, for example, it's happening. But the ability to do the model attributes, having attributes, and you can go quite deep. It enables quite a native, easy way to model time, not as just a timestamp, but actually the structure also of a certain timestamp in a very granular fashion. So those are the options available to you. How you decide to model that is, of course, up to you. The key thing that we've done is to build a model that is expressive enough to build and represent what you're trying to model.
Yeah.
Of course, without knowledge of your problem and scope and details, hard to, of course, give an answer. But those are the things that I would really emphasize. And really, frankly, just start building something and see how you get on, and share that with the community if you can.
Our stamp in the community is always start building.
Start building.
Start building.
Start building.
Absolutely. Our pleasure, Patrick. Our pleasure. Love it. Yes, and the video that I linked to is from Brett Forbes, as Tomas mentioned. Jump into Discord. Brett is, I believe, at Modeler, and he would love to talk through this.
That's for data modeler, not modeler in the fashion sense, but
yes,
modeler
correct.
in the data modeler, which I think is a brilliant name.
Yeah. So are there any other questions, comments, thoughts? Anything you want to leave us with? Yes, absolutely.
Please do. We disagree a lot between ourselves and here with our team, so.
That's the beauty of it, though. So it really encourage you to join us on Discord. And as I mentioned earlier, tomorrow we are hosting a comparison on graph databases and TypeDB. And then starting next week, we've got our community members coming out and delivering their presentations on the work that they've been doing. Really encourage you to check those out. And with that being said, wherever you're calling in from, afternoon, morning, evening, we're just glad you're here. Thank you for spending some time with us, and we will see you very soon.
Yeah.
Bye, everybody. Thanks a lot.
Bye.